Assalamu alaikum everyone. Welcome to another video of Chemistry with Sarab Dasame. In this video, we're going to revise the whole bonding chapter by solving two types of questions. Let's look at the first question. They're asking us to complete the following table. They have given us the name of the substances and they're asking us to fill in the bonding and the structure present in each of these materials. So like I said before, when I use the word bonding, three words should come to your mind: ionic, covalent, and metallic. And when I use the structure, two words should come to your mind, that is giant or simple. So let's fill in the table. If you look at sodium chloride, NaCl, it's a compound and it's an ionic compound. So bonding would be ionic. And since all ionic compounds are giant, the structure would be giant. Let's look at copper. It's just copper. It's not bonding with any other substance. That means copper is a metal. So bonding would be metallic. And all metals have a giant structure. So copper will also have a giant structure. Copper sulfate. Copper sulfate is also a compound. It's an ionic compound made up of a copper 2 plus cation and an SO4 2 minus, sulfate 2 minus anion. Hence this is also ionic. And the structure of copper sulfate would again be giant because all ionic compounds are giant. Diamond, it's just an allotrope of carbon. Diamond bonding, each carbon atom is covalently bonded to 4 other carbon atoms, so covalent. And diamond obviously has a giant structure. It's a giant covalent structure. Iodine, group 7. 2 iodine atoms joining together to form a molecule. It's a simple covalent molecule. So covalent, and the structure would be simple. Silicon dioxide. Each silicon is covalently bonded to 4 other oxygen atoms and each oxygen atom is covalently bonded to 2 silicon atoms. So this is covalent and giant. Ammonium chloride. Compound, ionic compound containing ammonium cation NH4 plus and chloride anion Cl minus. So it's ionic and all ionic compounds are giant. Potassium. Potassium again metallic bonding and all metals are giant. Graphite. Graphite. So graphite will have covalent bonding because each carbon atom is covalently bonded to 3 other carbon atoms. And graphite is also a giant covalent structure. Ethanol. In ethanol, we have covalent bonding again because these are all non-metals bonded to each other and the structure is simple. It's just 2 carbon atoms, 6 hydrogen atoms and 1 oxygen atom. So it's a simple covalent molecule. Glucose, again a simple covalent molecule. Ammonia gas, again ammonia gas, NH3 gas, just this molecule. 1 nitrogen atom, 3 hydrogen atoms. So it's covalent and simple with intermolecular forces present between ammonia molecules, glucose molecules, ethanol molecules. And oxygen gas again is simple covalent. Let's move on to the next example, and that is this question. These are some properties of substances A to G and they're asking us questions related to these substances. So which of the 7 substances are metals? We have studied that metals have a high melting and boiling point. Metals are not soluble in water. They will react with water. They're insoluble in water. And metals have a high melting and boiling point and good electrical conductivity. So let's see. Which of these 7 substances are metals? Metals will have a good electrical conductivity in solid and liquid both. So good electrical conductivity in solid is this and this. And D is also having a high melting point, good electrical conductivity, insoluble in water. And G also has a high melting point, good electrical conductivity in solid and liquid, and it's insoluble in water. Hence, I would say that D and G are metals. Which of the substances are ionic compounds? So when I talk about ionic compounds have a high melting and boiling point. They do not conduct electricity in their solid state, but they do conduct electricity in their liquid and molten state, and they are soluble in water. Ionic compounds are soluble in water. So this B is an ionic compound. 680 degrees Celsius is a high melting point, does not conduct electricity, poor electrical conductivity in solid state, good electrical conductivity in liquid state, and it's soluble in water. So B is ionic, and that is it. So which of the substances are ionic compounds? B is ionic. Now, and also E. If you look at E, E also has high electrical conductivity in liquid, but poor electrical conductivity in solid, a high melting point, and soluble in water. So B and E are ionic compounds. Let's look at option C. Two of the substances have very low melting points compared with the rest. Explain why these could not be ionic compounds. So two of the substances that have very low melting points are A and C. And they cannot be ionic compounds because ionic compounds have a high melting point. And these substances have a very low melting point and negatives. So they cannot be ionic compounds. D. Which of the two substances are molecular? Of course, molecular, simple covalent molecules. Again, it's A and C. A and C. Which substance is a giant covalent structure? Now, giant covalent structure will have a high melting point, but it will have a poor electrical conductivity in solid and liquid state, and it also won't be soluble in water. So that is going to be F. High melting point, poor electrical conductivity in solid and liquid, and it's insoluble in water. So which substance is a giant covalent structure? Substance F. What other name is used to describe this type of structure? So what other name? And hint starts with M. So what other name would be used to describe this type of structure? So that would be, hint starts with M. So that would be and then name the type of bonding found in B, C, E, and F. So B is, of course, ionic. C is, of course, covalent. E is, of course, ionic. And F is covalent. So this is how we are going to approach the questions of bonding, and this is how we have summarized the chapter of bonding. So I will see you guys in the next video.